This is GCSE Further Maths Pure. We're on chapter 5, differentiation, and we're now going to start to look at maximum and minimum turning points. So if we consider this curve here, goes up like this, down like this. At a turning point, the tangent to the curve is horizontal, therefore dy by dx is 0. Do you see that? So if we did a tangent there, that's not horizontal, but right up there at the top, there's a tangent which is running like that. Right down here, there's a tangent that's running like that. And those then are known as turning points. So it goes up here and it turns around and it comes back down and down here. And quite often finding turning points is very beneficial for helping us to sketch the curve. You know where kind of things change. And also we know the gradient then. So the gradient is 0. So if we set dy by dx equal to 0, we can find the turning point. At A, we have a maximum turning point. Obviously it's going up and then coming down. At B, we have a minimum turning point. There are two different methods to distinguish. Two different methods to distinguish whether turning points are maximum or minimum. Firstly, we could consider 2 points on the curve either side and very close to the turning point, and then calculate the gradients. You see. So here's your turning point. If I pick this point, it's going to be a positive gradient. Remember, it's going this way. If I pick this point, it'll be a negative gradient. So if we know the turning point is in between, then it must be a maximum. Here, it would be negative, then changing to positive. If the gradient changes from positive to negative, as x increases, then the turning point will be a maximum. If the gradient changes from negative to positive as x increases, then the turning point will be a minimum. The second and most common way of distinguishing between maximum and minimum turning points is to use the second derivative, d2y by dx squared. You hopefully remember that from a while back. If d2y by dx squared is less than 0, it's negative. And d2y by dx squared is greater than 0, then it's positive. Find the turning point on the curve and determine its nature. So we're going to find dy by dx, which is going to be the 3 is going to disappear, so that's then going to be minus 4 plus 2x. At the turning point, and this is a new bit for us, at the turning point, dy by dx equals 0. Therefore, 0 equals minus 4 plus 2x. Therefore, 4 is 2x, and that gives us then x equals 2. So that's our turning point there. And we have that now. We space over leaf then. We kind of find the nature of it. I hope we do. We found the x coordinate. We now need the y coordinate. So we're subbing in y equals 3 minus 4 upon 2. Substitute my 2 then for my x there. Plus 2 squared. You calculate that, then you're going to get minus 1. Maybe you have 3, take away 8 plus 4, so it's minus 1. Therefore, turning point at 2 minus 1. Okay. Space over here, otherwise we're in trouble. And a bit of space, so we're fine. So we're determining the nature of the turning point. We'll go for method 2 first because it's nice and straightforward. Probably call it method 1, shouldn't I? Method 2, d2y by dx squared. Remember, then we're just going to differentiate that again. So here was my dy by dx. If I differentiate this again, the minus 4 disappears and I just end up then with a 2. So dy by dx squared gives us 2, and 2 is of course greater than 0. If it's greater than 0, again let's look back here. If it's greater than 0, then it's going to be a minimum. It's a minimum turning point at 2 minus 1. Just very quickly, if we go for method 1 then, don't want to spend too much time on it. So if I do then a wee table and pick some points just in between, we know that at x equals 2, the gradient is 0. So if I pick some points just before that, I should be able to work it out. So x and dy by dx, that's going to tell me my gradients at the point that I want it. So 2, we know it's 0, that's what we worked out. So let's try 3, and let's try 1, again dy by dx. If you remember it back up here, was this. So if I put 3 into here, that's going to be minus 4 plus 6. So that would be 2, that would be a positive number. If I put the number 1 into this, minus 4 plus 2 is going to give me minus 2. The gradient of this, minus 2, so it's going to go like that. Here, the gradient's like that. Here, the gradient's like that. Therefore, it's a minimum. Turning point at 2, minus 1.